All right, this is a redox reaction, a balancing of a redox reaction, and it was on I believe it was on a quiz. So let's walk through it. We're balancing this redox reaction in basic solution. There's a set of steps we have to go through, so let's just jump in and go through the steps. First one is to split up the redox reaction into the half reactions, and so I'll pull out the zinc. You want to be very careful transcribing subscripts and superscripts and charges, because if you get them wrong, you will never get the question right. So here we go. First thing, make sure that the zinc is balanced, and it is. And then we're going to balance the oxygens with water. And so we have 4 H2Os. And then we're going to balance the hydrogens with H pluses. This is basic, but we'll go ahead and balance with H pluses, and then we'll get rid of them later with OH minuses. So it looks like I have 8 H's on the right, but notice that I also have 4 times 2. I've got 8, oops, not 8. You want to be very careful, because if you get this wrong, you'll never get the problem right. I have 4 H's on the right and 8 on the left, which means I need 4 H pluses on the right. I could get rid of them now. I'm going to wait until later to get rid of them. Either way, I'm going to wait till later. All right, at this point, we balance the electrons, balance the charge using electrons. On the left, the charge is 0. And on the right, the charge is, I've got a -2 plus 4. So I've got a +2 on the right, which means I need 2 electrons to balance it. I want to double check everything at this point, because if I've gotten this wrong, I will never get the right answer. And this is take 2 on this video, by the way. And I kept saying that through that whole first take. If I get this wrong, I'll have to scrap this video and start over. And I did have to scrap it. So 2 electrons on the right. Charge on the right is negative -2 plus 4 minus 2, so 0 and 0. I have 1 zinc on each side. I have 4 oxygens on each side, and I have 8 hydrogens on each side. So that one looks good. Let's grab the other half reaction. I've got NO3 with a negative going to NH3 on the right. I balance the nitrogens, and I see that I do have 1 on each side, so that's good. Then I balance the oxygens using water. I've got 3 oxygens on the left, and so I need 3 H2Os on the right. Then I balance the hydrogens with H+. I've got 3 of them there and 6 of them there, so I've got 9 hydrogens on the right, and so I need 9 H pluses on the left. Then I balance the charge. I have +9 minus 1, or a +8 on the left. I do have a 0 charge on the right, and so it looks like I need 8 electrons on the left to balance it. I'm going to do a quick check, make sure I haven't missed anything, because if I get this step wrong, I have to start over. I scrap this video and start over. All right, so on the left, I have a charge of -8 plus 9 minus 1, or 0. 0 on the right. 1 nitrogen on each side, 3 oxygens on each side, and 3 plus 6, or 9 hydrogens on each side. So I think I've got it this time. This is where I went wrong last time. All right, next, I'm going to balance the charge. So I have 8 electrons on the left, 2 on the right. They are on opposite sides. That's a good sign. It looks like I need to multiply this half reaction by 4 in order to balance my electron transfer. So I'm going to rewrite that top reaction times 4. I'm going to put it right here below this reaction. And here we go. So 4 times 4 is 16 H2Os plus 4 ZNs goes to 4 ZnOH4 -2. 4 times 4 is 16 H pluses and 8 electrons. Again, at any point now, I could cancel the H pluses by adding waters. I'm going to wait to the very end, because sometimes you get them canceling. You'll notice that I do have 8 electrons on both sides. That's a good sign. It has to be. It's not just a good sign. It has to be. So let me handle the waters next. Notice I have 3 waters on the right and 16 on the left. So let's get rid of those 3. That leaves me with 13 H2Os on the left. Then you'll notice that I have 16 H pluses on the right and 9 on the left. Let's get rid of those 9. And that leaves me with 7. Is that 7? Yep, 16 minus 9 is 7. And so at this point, all I have to do is cancel those 7 H pluses. So let me go ahead and write that reaction with the 7 H pluses over here on the left, which means I'll have 7 OH minuses on the left and 7 waters on the right. And now I can cancel a few more waters. 13 minus 7, is that 6? 6 plus 7 is 13. Yep, I think that's it. And that cancels my 7 H pluses. So let me rewrite, let me add these reactions up, and let's see if we got the right answer this time. So NO3 minus plus 6 waters plus 4 zincs plus 7 OH minuses. All of that is on the left. The NO3, these guys canceled. I'm left with 6 water, 4 zincs, and 7 OH minuses. There we go. On the right, I have NH3 plus 4 ZNOH, 4 negative 2s. Let's see, all my H pluses canceled, my electrons canceled, my waters canceled. There we go. Hey, I got the right answer. I go through and I add up all the coefficients. Remember that if there is not a coefficient written, it is 1. And so the coefficients, the sum of the coefficients of the products is 4 plus 1 or 5. All right. I would like to point out there's a little bit of a shortcut here once you get good at these. If I take this top reaction, let me rewrite it down here. Oops, nope. Yeah, let me take this top half reaction. If I look at just this top half reaction, let me start from the beginning. Zinc. This is just a little bit of a shortcut if you catch it. If you don't, the long way does work, but it is the long way. I started with this half reaction, and remember we're balancing it in basic solution. And what I might recognize right away is, hey, I can balance that with OH minuses. That is one of the techniques if you go digging around the internet. It's not the one that I teach, but it does work. But it only works if it works nicely. And in this case, it does work nicely. That means I have negative 4 on the left for my charge, negative 2 on the right, which means I need 2 more electrons here. I end up with the same number of electrons for that half reaction, but I skip the point of adding H pluses. Now I still have to add H pluses to my other half reaction. I'll still have to cancel them, etc. But it's a little quicker. It gets rid of the H pluses in that first half reaction and skips right to the OH minuses. So, and from here, you would go on and balance the second half reaction, add them together, etc., just like we did before. It just gets rid of some H pluses early on.